Hello guys, good morning everyone. Hope you would be good. And so today we study limit, 11th class topic limits, and we'll solve some questions from limit. So let's like we have first question. Limit extends to infinity, square root of 1 plus x square minus x. Here we have a limit tends to infinity. So what we'll do here. We'll rationalize this function. So it will be very easy to determine limit. Otherwise, we'll put here limit extends to infinity. So we'll not get a proper uh, integer or any fraction for that. So limit x tends to 0. We'll just rationalize and 1 plus x square minus x. Rationalize, we'll take conjugate. So we have a conjugate 1 plus x square plus x, and here we have 1 plus x square plus x. So it will become, okay, limit x tends to infinity, not 0. X tends to infinity. It will become a square minus just algebraic identity. So 1 plus x square minus x square upon square root of 1 plus x square plus x. Right? So x square plus and minus, it will be cancelled out. Limit x tends to 0. We have here not whole under root 1 plus x square plus x. Now we can put limit. So we'll put limit here, x tends to infinity. So just we'll get 1 upon infinity. It means just 0. Right? So we have answered C. Next question. Here. We can see here again limit n tends to infinity, but we'll see common term here, 1 upon 1 minus n square. This is common, so we'll take it common first. Limit n tends to infinity. So 1 minus n square, we take it common, and remaining 1 plus 2 plus 3 up to n. So we can see here we have numbers, just counting numbers, and it's called natural number. They are just natural number, and we know the first n natural number, sum of first n natural number. So we know the sum of the first n natural number, which is n into n plus 1 upon 2, right? So what we'll do here now next, again limit n tends to infinity, and we'll factorize it. So it will become n minus 1 and n plus 1. Here we have n into n plus 1 upon 2. So n plus 1 and plus 1 will be cancelled out, and so we have limit n tends to infinity. So we'll write here minus n upon twice n minus 1, right? So now we'll take n common, because we have limit n tends to infinity. So here it should be it should become 0. So we'll take n common, so that this n will be cancelled out. So limit n tends to infinity, and minus n upon, we'll take common n. So here we have 1 upon n. So this n and this n get cancelled, and so now we'll write limit n tends to uh, infinity, and we have 1 upon minus 1 upon n. Now put limit here, and we'll put limit here. So 1 upon n, it will become 0. So 1 minus 0, that is 1, and 2 into 1, 1, and so we'll get limit minus 1 by 2. This is the limit. So then answer C. So let's go to next question. Question number 3, we have a function square root of x minus sin x upon x plus cos square x, and limit x tends to 0, limit of f of x. We need to find limit of f of x. 8 x tends to infinity. So what we'll do here, limit x tends to infinity, and we have a function like that, x minus sin x and x plus cos square x. So we have limit x tends to infinity. So what we'll do first, we'll take x common here, x common. So limit x tends to infinity, and if we take x common, so 1 minus sin x upon x, and again 1 plus cos square x upon x, right? So now we'll put limit x tends to infinity. So it will become 0, because sine infinity will give us something value between minus 1 to 1. It will not be a 0, and because we are going to put a limit x tends to infinity. So we couldn't determine the fixed value for sine, but we know sine infinity gives us value between minus 1 to 1, right? And upon x, so for that it will become 0. And again here cos square x, so cos function will also give us value for cos infinity, will give us value that will be between minus 1 to 1. So again we'll put limit here x, x, then it will 1 upon x, and we'll put limit x tends to infinity, so it will become 0, right? Next, so finally we have 0 here and 1 plus 0. So what is the answer we have? Plus 1. So A answer. It's fine. Next question. Limit x tends to 0, and we have expression sine x degree upon x. So first we'll convert x degree in radian measure. So how can we convert any degree measure in radian measure? So limit x tends to 0. Also I'll write here sine x pi into 1 upon 80. So, and here, so now we know limit x tends to 0, and if we have a sine x upon x, so this is just formula we can understand, and this limit, this expression for x tends to 0 will give us 1. So here we will make same expression, because angle and this domain and here the upon value should be same. So limit x tends to 0, and we'll write here sine pi x upon 180, and here x into pi upon 180, and so we'll also multiply in both numerator and denominator pi upon 180. right? So because if we want to go get back in same function, so these will be cancelled out. Mhm. So we have a now this thing like we can write again for understanding x tends to 0, sine pi x upon 180 upon pi x upon 180. So here we have a pi upon 180 in multiply. So this will become 1. If we put limit, so this will become 1. And so finally we have pi upon 180. And that's the answer. So answer D. Mm. Next question number 5. Mm. Question number 5. So again, we have a question from rationalization. So limit x tends to 0, and we have a x square root of 1 plus x minus square root of 1 minus x. So we'll multiply the conjugate of this denominator. So we have a 1 plus x minus on conjugate, we'll take just opposite sign, 1 minus x on 1 plus x plus 1 minus x square root of. And now we'll write here limit x tends to 0 and 1 plus x 1 minus x upon. So it suggests a minus b into a plus b, that is algebraic identity, which is a square minus b square. So it will become a square root of 1 plus x will become 1 plus x and minus 1 minus x, a square minus b square. Limit x tends to 0, and here we have 1 plus x plus square root of 1 minus x upon 1 plus x minus 1 minus x, right? So it will be cancelled out, and limit x tends to 0, and so we have now 2x, x plus x, and this will be cancelled out, right? Now we'll put the limit x tends to 0. So we'll put limit x tends to 0. So what we'll get upon in numerator? Numerator we have 1 plus 1, and here 2. So we'll get answer 1, right? So answer C. Answer C. Question number 6. What is the option? Question number 6. If fx is differentiable and strictly increasing function, then limit x tends to 0. F of x square minus f of x upon f of x minus f of 0 is equal to, we need to find limit 8x to 0. Yeah, we have these options. So limit x tends to 0, and we have a expression f of x square minus f of x upon f of x minus f of 0. Now if we put the limit x equal to 0 here, so we'll get f of 0 minus f of 0 upon f of 0 minus f of 0, means we'll get 0 upon 0 form. It's an indeterminate form. It's an indeterminate form. So what we'll do here, if we have an indeterminate form 0 by 0, so what we'll do, we'll apply L hospital. So L hospital, what is L hospital? We'll just differentiate numerator and denominator distinctly, right? So limit x tends to 0. So we'll differentiate numerator first. So f dash x square, and now we'll differentiate x square. It's a just chain rule, and minus f dash x. Now f dash x minus, it's a just constant. F of 0, it's a constant value, so it will become 0, right? Now limit x tends to 0, and we can write in this form, right? F of 2x into f dash x square upon f of x f dash and minus 1. We have broken the LCM, like, so it will become minus 1. It will become minus 1, and this is the expression. So limit x tends to 0, and now if we try to put limit here, so what will be the answer? We'll get like 2 into 0 and f dash 0 square, which is 0, and f dash 0, right? And you can see here f dash 0, we have given in question, we are given the question, right? Fx is a differentiable and strictly increasing, means strictly increasing means f of f dash f prime x will be greater than 0, so it will not be 0. So f dash of 0 will also give us value, something that will be greater than 0. So that's why those value will be cancelled out here, we can understand here. And but finally we are going to these expression with we are going to multiply these expression by 0, so that for what we'll get result, we'll get 0, right? So that's the answer A. That's fine, I think. No issue in this. And just we differentiate, we apply here L hospital rule, L hospital, and then we differentiate numerator and denominator separately. We have a next question. So limit x tends to 0 and of fx is equal to. So we have to find limit x tends to 0 of fx. It means we have option does not exist. So it means we'll check limit LHL and RHL both. So if both are equal, so it means limit exists, and if both are not equal, so in that case limit does not exist. So LHL, for LHL, limit x tends to 0 minus LHL 0 minus, because we are going to check limit 8 x equal to 0. So we will take x tends to 0 minus, and for 0 minus, it means value just less than 0. Just less than 0 is means the value of x just less than 0. So we'll take first definition. We have three definition here. So function is broken in three parts based on different definitions. So first definition, x less than 0. So we'll take here x, right? And now limit h tends to 0, and what we'll put here? We'll put here 0 minus h. I think, do you know how to take LHL and RHL? So limit h tends to 0, and we have minus h. Now we'll put limit, so we'll get 0. So LHL we have 0, LHL equal to 0, and now we'll take RHL, so that will be x greater than 0 plus, right? So 0 plus means something, a value of x that is greater than 0. 0 plus means 0 just greater than something value can be added to 0. So we'll write here x square, right? So limit h tends to 0 and 0 plus h whole square. So what is limit h tends to 0, this will become h square, and now we'll put limit, so we'll get 0, right? So both limit, here we have RHL, RHL, and here LHL, so both are equal, so it means limit is equal to just 0, so answer is A. Question number 8, again we have question, and we have option does not exist, so it means we'll check both limits, LHL and RHL. So we'll take here limit x tends to 0 minus, right? And then we'll write plus 1 plus e raised to the power 1 up minus 1 upon x. Here we have 1 minus e raised to the power minus 1 upon x. So what is the meaning of limit 0 minus? So we'll take limit h tends to 0, and here we'll write 1 plus e raised to the power minus 0 minus h, right? And we'll write 1 minus e raised to the power 0 minus h, right? So now limit h tends to 0, and we have a 1 plus e raised to the power 1 upon h, right? And now we'll put 1 minus e raised to the power 1 upon h. You can see here, if we'll put a limit directly here, so e raised to the power infinity 1 upon h and 1 upon 0, so it will become infinity, e raised to the power infinity, so we'll get infinity upon infinity form. It's just indeterminate form, right? So what we'll do here, we'll take e raised to the power 1 upon h common, right? So first limit h tends to 0, and we'll take e raised to the power common. So what we'll get here, so we'll get here minus e raised to the power minus 1 upon h, and here plus, right? Again e raised to the power not 1 upon h, and just e raised to the power minus 1 upon h, and then minus 1, right? So this will be cancelled out. So what we have, a limit h tends to 0, and limit minus 1 upon h plus 1 upon minus 1 upon h minus 1. All right. So we'll put h tends to 0, h equal to 0 when we put the direct limit. So we'll substitute limit. So what will happen? We'll get here 1 upon like this. So here we'll put limit 0. So e raised to the power 1 upon h. E raised to the power 1 upon 0. So e raised which means e raised to the power infinity. E raised to the power infinity. So then we have infinity. So 1 upon infinity. 1 upon infinity will become 0. So finally we have here 0 plus 1, and then here also 0 minus 1. So what is the value here? We have minus 1. So we have a LHL, which is minus 1, right? Now we'll take RHL. So in RHL, again limit x tends to 0 plus, right? So similarly, same here, e raised to the power minus 1 upon x upon 1 minus e raised to the power minus 1 upon x. So we'll write here h tends to 0, and what we write here, 1 plus e raised to the power minus 0 plus h, right? And we'll write here 1 minus e raised to the power 0 plus h, right? Now limit h tends to 0, and 1 plus e raised to the power minus 1 upon 0 plus h, which is 0, not 0, h, and minus e raised to the power minus 1 upon h, 0 plus h, h. So we have, now again we'll put a limit here. So we'll get 1 and 0, 1, minus 0. Here we have minus, right? So we can understand here 1 upon 1, which is 1. So we have a RHL, which is 1, and LHL minus 1. So both limits are not equal. So that's why limit does not exist for this expression. That's the answer. That's all. So in this question, I think just we need to understand how can we take both limits, left hand limit and right hand limit. And for right hand limit and left hand limit, we just take, convert in a h function, right? So then it will become very easy. Hmm. Okay, so now we have a function g function, and we need to find limit extends to 1 of this expression. So first we can see here, right, if we'll put limit 1, so we'll get g of 1 minus, we have already g of 1, and upon 1 minus 1. So g of 1 minus g of 1, which is 0, and upon 1 minus 1, which is also 0. So we have a form 0 upon 0, and it's a totally indeterminate form, right? So when we have an indeterminate form 0 upon 0, so what we will do, we'll apply L'Hospital. So L'Hospital limit x tends to 0, and so for L'Hospital, g dash g prime x minus, and g of 1, which is just a constant function, right? So it will become 0. Differentiate, we are going to just differentiate numerator and denominator separately. So differentiate x, which is 1, and minus 0, right? So now limit not x tends to 0, limit x tends to 1. So limit x tends to 1, and now we need to differentiate function g, right? So we'll differentiate g dash, which will become, we'll apply just chain rule, and first we differentiate square root, so it will become 1 upon 2, 1 upon 2 into 25 minus x square, right? And we have here minus, and now we'll differentiate function under square root. So we have 25. What happened? Yeah, so we have 25, so which is just constant, so it will become 0, and minus x square, differentiation of x square, which is 2x, right? So we'll write here 0 minus 2x minus 2x, and minus minus plus, so 2x upon 2 square root of 25 minus x square. So in 2 cancel, so we'll write here x upon 25 minus x square, right? So now we'll put limit here, so x equal to 1, so we'll substitute limit direct. So 1 upon square root of 25 minus 1 square, which is 1, and 1 upon square root of 24. So that's answer. So it means this is the answer. Answer A. Option will be A. Next question. We have a limit. Again, we have function, same kind of function. If we'll put limit x equal to a in this function direct, we'll substitute the limit. So what kind of form we'll get? I think we'll get 0 by 0 form, right? 0 by 0 form. We have 0 by 0 form. So in this case, what we'll do, we'll apply L hospital rule. So I'm going to apply direct L hospital rule. A limit extends to A, and it's a g of x. It's a function, so the differentiation will become g prime x, right? And f of a, it's just constant. F of a, it's constant, so it will be as it is. And again, g of a is also constant, so it will be written as it is. And f of x, which is function and can be differentiated, f dax x. And we have a denominator, in denominator x minus a, which is 1 minus 0. Now we'll put the limit, we'll substitute limit here. So g dash of a times f of a minus g of a times f dash of a, right? So we have all the values given in the question. So we'll do g dash of a, which is 2. So we'll write 2. And f of a, which is also 2. So substitute 2. And g of a, which is minus 1, f dash of a, which is 1, right? So 2 to the 4, and minus plus 1 1 ja 1. So 4 plus 1, which is 5. So that's also 5. That's all. Right. So what we'll do here, first apply limit. We know limit x tends to not infinity, x tends to 0. X tends to 0 and 10x upon x. This is just formula and gives us 1. So if we apply limit, so we'll get 1, but we have 1 upon x square. So we'll substitute limit here over here. So what we'll get? Infinity. So 1 raised to the power infinity. It's just an indeterminate form, right? It's a indeterminate form. So what we'll do here? We can solve by this formula, like we'll write e raised to the power limit x tends to 0, not infinity. X tends to 0, and now we have limit 10x upon x minus 1 and 1 upon x square. Now we will write in multiply x square, right? So e raised to the power limit x tends to 0. What we'll do here? We'll solve it and we'll write expansion of 10x, right? So for expansion of 10x, which is x plus x cube upon 3, x or x cube upon 3. Yes, which is right. And 2 upon 15, x raised to the power 5 up to so on. We have here x, and we'll take minus 1, and now x square. So e raised to the power limit x tends to 0. Now we are going to neglect higher powers because we have limit x tends to 0. So we'll substitute x equal to 0. So then those will become 0. So now we are going to neglect them. So we'll write here x plus x cube upon 3, right? And we have here x minus 1 upon x square. So I write here limit x tends to 0. So we'll take LCM x plus x cube upon 3 minus x upon x, and which is x square. So limit and we have here x and minus x will be cancelled out, so we'll get x cube upon 3x cube, right? We have x cube and x square into x square, and 3 will go to and denominator. So this will be cancelled out, and now we'll put limit, so we'll get 1 upon 3. So this is the answer. I think e raised to the power, right? So again we have question number 12. Question number 12, so we try to solve it. Limit x tends to infinity, right? Infinity, and we have x raised to the power n upon x e raised to the power x. It was a negative power, so we have written in denominator. So x raised to the power n upon e raised to the power x. So now if we apply here, so we substitute limit, so infinity upon infinity, so just indeterminate form. So what we'll do again, we are going to apply L'Hospital, right? So for L'Hospital, so if I differentiate numerator, so n raised to the power n, n into x raised to the power n minus 1, right? And if I differentiate it once again, so what I'll give, I'll get n minus 1 x raised to the power n minus 2. So if I'll differentiate once again, so n minus 2 x raised to the power minus 3. So I'll we'll differentiate it, last, like we can understand power 1, like power 1, when we'll get power 1, so till then we'll differentiate it. So n minus 3 and up to it will be 1, right? At the last we'll get only x, and then differentiation of x will be 1, right? And you can understand before that 2 and 3 in this way. So now we have e raised to the power, and in denominator, if you differentiate e raised to the power x n times, so there is no difference. We'll get just every time e raised to the power after differentiation. So limit x tends to infinity, and now n into n minus 1 into n minus 2 n minus 3 up to 3 dot 2 dot 1. So what is this? It's a factorial n. It's factorial n, I think, n e raised to the power x, right? So now we'll put limit. So we don't have here x in, but in limit in denominator e raised to the power infinity, which is just infinity, and we have in numerator denominator infinity, so it will become 0, right? So it will become 0. So we have answer D. Because we can write factorial n, it's just infinity, and we can understand infinity, which is 1 upon 0, right? So when we would be solving it, so we'll get 0, right? So that's question number 12. Now question number 13. Question number 13, and these are the options. So again, I think we have a 0 upon 0 form, and it's just indeterminate form. So if we apply L hospital, so it will become long, right? Because we have in denominator x square. So if we want to remove x square, so we'll have to differentiate this expression twice. And another thing is that if we'll differentiate expression in numerator, so we have log x. So if we'll differentiate it twice, so it will be some difficult, right? So what we'll do here, we'll try to write expansion of these functions, right? Limit x tends to 0 and x into expansion of cos x, which is 1 minus x square upon factorial 2. And we'll just write two terms because remaining terms will become 0, higher powers, and we have a limit x tends to 0. So those powers will become 0. So I write here this expansion of log 1 plus x, which is x, and minus x square upon 2, and x square upon 2, right? And we'll write just two terms, okay? And now we have x square. So it will be very simple. I think it's pretty simple, and we can solve it. We'll multiply x minus x cube upon factorial 2, which is also 2. And now minus x and minus plus in x square upon 2, right? We have x square, this is cancelled out, and we'll take x square common. We'll take x square common. So we'll take x square common. It means we have here minus, and expansion is also x minus, right? So it's fine. It's fine. I think we'll take x square common. So we have x upon 2 and then plus 1 upon 2, right? Then x square. So these are cancelled out. Now we can substitute limit direct. So we'll substitute limit 0 upon minus and then 1 by 2. So we have 1 by 2. I think it's right. We didn't make any mistake here. Yeah, so that's question number 13, and we have answer 1 by 2. Question number 14, and these are the options. So question number 14, limit. So first we can check what is we have what is indeterminate form in front of us. So put limit here x, substitute limit x tends to 9. So f of 9 minus, so value of f of 9, which is also 9, so square root of 9, it's a perfect square, so we'll get 3, and 3 minus 3, which is also 0, right? And here we'll put limit x equal to 9, so square root of 9, 3, and 3 minus 3, which is also 0. So we have a 0 upon 0 form, so it's a totally indeterminate form. So what we'll do here, we'll apply L hospital rule, right? So what is L hospital rule? In L hospital rule, we'll differentiate numerator and denominator distinctly. So 1 upon, we'll differentiate, it's just apply chain rule, and we'll differentiate first square root of fx. So first we'll differentiate square root, so which is 1 upon 2 into square root, and now we'll differentiate fx, so which is f dash x, and 3 is just constant, so it will become 0, right? Now again we'll differentiate square root, so this will become 1 upon 2 into square root minus 0. And here we will, after first you differentiated square root and then you differentiate x, so it will become 1, right? Now 3 is constant, so we don't have a limit 0, we have limit 9. Limit extends to 0. First you can, I think this 2 and you cancel out, so we have f dash x upon square root of fx, and here we have 1 upon square root of x, right? Now put the value here once again. So f dash of 9 upon f of 9, right? And we have here 9. So f dash of 9, we have 4, right? So value of 4. And here we'll write f of 9, which is 9, right? And 1 upon f of 9. So we'll get here 4 upon 3, and it will become 3 upon, right? So then 3 cancel, and we'll get 4. So that's the answer. And that's all. Question number 14. Question number 15, and these are the options. So again, we'll put, if so we have infinity here, right? If we put limit x equal to 0, so we have infinity. So what we'll take LCM first. We'll take LCM. So that's x square and sine square x. Sine square x minus x square, right? So limit x tends to 0. Now we don't have any other option. If we apply L hospital rule, so it will not be fit for it. So that's why we'll write expansion of sine, right? So then I think whoever is fault here, like x square, and they are making this expression infinity, those will be cancelled out. So expansion of sine, which is x minus x cube upon factorial 3. I'll write only first 2 terms. Remaining terms will be negligible because we have limit x tends to 0. And now square minus x square. Again x square, and we have x minus x cube upon factorial 3, right? And we have square. So I'll write here limit x tends to 0, and try to so we'll open the square, whole square, so x square and plus x raised to the power 6 upon factorial 3, which is 6, and square, then become 36, right? And minus minus x raised to the power 4, and we have upon 6, but we have 2ab, so 2 will be cancelled out, so we'll get 3, right? Minus x square, and again we have x square, and here we'll get x square plus x raised to the power 6 upon 36, and minus x raised to the power 4 upon this. Right, so this x square and this cancelled out, and now we have limit x tends to 0, and we'll take x raised to the power 4 common, right? So x raised to the power 4 common, so we have here x square. What is left out? X square upon 36, and here 1 upon 3, then x square, and again we'll take x square common from here, so it will become x raised to the power 4 and 1 plus x raised to the power 4 upon 36 minus x square upon 3. Right? So x raised to the power 4 and x raised to the power 4 will get cancelled. So we now we can put limit here. So this term will become 0 and this also will become 0. So we have minus 1 by 3 upon 1. So minus 1 by 3. That's the answer. So minus 1 by 3 means we have D option. We have D option. That's all, and it was 50 question number 15. Hmm. Now look at this. We have a D option, and which is does not exist. It means we'll check both limits, LHL and RHL. So limit x tends to 3 minus, right? Limit x tends to 3 minus. So x minus 3 upon modulus of x minus 3. So now we'll write limit h tends to 0 and 3 minus h minus 3, right? And limit modulus 3 minus h minus 3, which is this. And now limit h tends to 0 and 3 plus 3 and minus 3 will cancel out, and we have minus h, right? And again we have minus h. So limit h tends to 0, we have minus h upon plus h. Modulus will give us positive h, right? So this will be cancelled out. We'll get limit h tends to 0. We have minus 1, and now we'll substitute limit. So we'll get minus 1, right? So we have LHL minus 1. Now we'll find out RHL. So limit x tends to 3 plus, right? So we'll write here same function first, x minus 3 modulus of x minus 3. So now we'll put h tends to 0, and we'll put here 3 plus h minus 3 upon 3 plus h minus 3, right? So limit h tends to 0. Again we have h, because 3 plus 3 and minus 3 will become 0, and here also same. So we get modulus of h. So limit h tends to 0, h upon h, right? It will become 1, and now we can substitute limit direct, so we will get 1. So we have LHL minus 1 and RHL plus 1. It means limit does not exist, both limit are not equal. So in that case, limit does not exist. So option will be D. So whenever we have a limit does not exist option. So we need to check LHL and RHL, right? And there is a difference between the limit does not exist and the value of the limit is infinity. It's totally different. Limit value of the limit of any function is infinity. It means we have something, but a limit does not exist. It means we don't have a limit, and RHL and LHL is not equal or not equal. And but it limit is infinity. It means both limits like LHL and RHL are equal to infinity. So in that case, limit exists. But if both are not equal, RHL and LHL is not equal, it means limit does not exist. Both value are not equal. But in that case, both values are equal. So it's a difference, infinity and between limit does not exist. So we have question number 17. So these are the options. So if we put here limit first, so you can see which indeterminate form do we have. So limit x tends to infinity, and we'll take x common. So if we have x common, so 1 plus 2 upon x and 1 plus 1 upon x. And now we have x power raised to the power x plus 3, right? So now we can put limit here. If we'll put, so we'll get 1, because this 2 upon x after substituting limit infinity. So we'll get 2 upon x, which is 0, and which is also 0. 1 plus 0, 1 plus 0, which is 1 upon 1, and we'll get 1. So but here infinity. So we have an indeterminate form 1 raised to the power infinity, and then whenever we have a indeterminate form 1 raised to the power infinity, so we'll write exponential form e, and limit x tends to infinity, and we'll write in this form x plus 2 upon x plus 1 and minus 1, and then this x plus 3 will be written in multiplication form, right? So e raised to the power limit extends to infinity. Limit extends to infinity, and we'll take LCM here. So x plus 2 minus 1 upon x plus 1. Here we have x plus 3, right? So x and minus x will be cancelled out, and limit e raised to the power limit x tends to infinity, and what we have 2 minus 1, which is 1. It will not create any difference, so just we'll write x plus 3 and x plus 1, right? Now we have limit x tends to infinity, so what we'll do, we'll take x common, and then we'll substitute limit x tends to infinity. So limit x tends to infinity. Whenever we have a limit x tends to infinity, so in that case, try to function and x 0, right? Try to make function 0. So we'll take common x, so 1 plus 3 upon x, right? And 1 plus 1 upon x, right? So e raised to the power and x raised to the power infinity. So now we'll not write this. We'll just write, we'll substitute limit. So if we substitute here 3 upon infinity means 3 upon 1 upon 0. So it will become 0, right? So here 1 plus 0 upon 1 plus 0, which is e, right? 1 plus 0, 1 plus 0, which is 1. So e. So what is option? Option is B, right? That's question number 70. Now we have question number 18. Again, I think we have same format. We'll put limit here. So we'll put limit here. So 10 pi by 4 plus 0 means 10 pi by 4, and 10 pi by 4, which is 1. And we have a 1 raised to the power infinity. So same form. So what we'll do here, we will write first 0, and we'll expand it. We'll write a 10 formula, we'll apply formula 10a plus b. So which is 10a. 10a means 10 pi by 4, which is 1, plus 10b means 10x, and upon 1 minus 10a 10b. So 10 pi by 4, which is 1, into 10b, which is 10x, right? And power 1 upon x. Now we'll write in this form, exponential form. 1 plus 10x upon 1 minus 10x minus 1, and here we have 1 upon x, right? So limit x tends to infinity, and we'll take LCM. So what will be the answer? We'll get 2 10x upon 1 minus 10x into 1 upon x, right? Now look at e raised to the power x tends to 0. So we'll write in this form 2 upon 1 minus 10x, right? And we'll try to write 10x separate. 10x upon x. We know for limit x tends to 0, this function 10x upon x will give us 1, right? So that's why we have written this separate. And now we have a 2 upon 1 minus 10x, right? So if we apply limit here, so 10 0, which is 0. So 1 minus 0, it will not create any undefined situation. So we'll substitute limit directly. So 2 upon 1 minus 0, and which is 1. So we have ultimately e square, right? E square, that's the answer. So answer C. Question number 19. These are the options. So again, I think we'll put limit here, and tends to infinity. So it will become infinity, and then finally it will become 0, because 1 upon infinity is 0. So 1 plus 0, which is 1. And here we have infinity. So we have a 1 raised to the power infinity form, right? So in that case, I already told you in previous some questions what we have to. So I'll write limit n tends to infinity, and 1 plus 1 upon a plus bn raised to the power c plus dn, right? Now e raised to the power limit n tends to infinity, and 1 plus 1 upon b plus bn minus 1 c plus dn, right? So these are cancelled out. E raised to the power we take exponential form, and we have here c plus dn upon a plus bn, right? And now if we'll substitute limit, so I think first we'll take n common. So e raised to the power limit n tends to infinity. So I'll take n common, so c upon n, and here d, right? And again n common, so a upon n minus, not minus, plus that is b, right? And will get cancelled out. E raised to the power limit n tends to infinity, right? So we have c upon. Now we can put limit directly. Don't write next steps. So we'll put limit n tends to infinity here. Substitute limit, so it will give us 0, and then 0 plus d, and here also we'll get 0 0 plus b, which is b. So e raised to the power d upon b. I think that's answer. So d upon b. So option A, right? That's all. And that was question number 19. Question number 20. It's a degree. We need to apply some theorem in this question. So what we'll do, we'll write in summation form first. So in summation form, I think we can limit in summation form n equal to 1 to infinity. We can write in this form, right? And we have r square upon r cube plus we write rth term first, right? It's a r term, and summation means we have to add all the terms while putting n equal to 1, n equal to 2, n equal to 3. So we'll many terms up to infinity, the terms will be generated, so we need to add them, right? So so how to solve these questions? So first we'll try to write n equal to 1 to infinity. We'll take n cube common, right? So r square and n cube common. So here will become r upon n cube, right? Plus 1. And in next step, n equal to 1 up to infinity. So r upon n square, right? From n cube, I'll separate n square and I write n square together r square. So we have r upon n whole cube plus 1. And now we have n. So we will convert this expression into integration. So how can we integrate integration? So 1 upon not 1 upon r upon n will become x, right? So it will become x square. So again r upon n, it's x, x cube plus 1, and 1 upon n will be tx, right? And limit will become 0 to 1. So now we can, I think, integrate it very easily, right? Integrate it. So we'll apply substitution method, I think, and we can consider t equal to x cube plus 1. So dt equal to 3x square dx, right? So I think limit 1 to infinity and 1 by 3 and not we'll write direct 1 by 3, and it will become log t, right? Log t, and value of t x cube plus 1, right? And limit 0 to 1. So we have now put limit, upper limit and lower limit. So it will become log 2 minus, when will you put limit 0? So log 1. You know the value of log 1 is 0. So ultimately we have 1 by 3 and log 2. That's answer. I think we have option. So 1 by 3, 1 upon log 2. That's the answer. That's question number 20. And now we have question number 21. These are the options. So again, put limit here. So I think we have a limit form independent indeterminate form 1 raised to the power infinity, because if you put limit x equal to 0 here and here, so it will give us 1, and 1 upon 0 it will give us infinity. So we'll write, we have a 1 raised to the power infinity form, so we'll write in exponential form, e raised to the power. E raised to the power x tends to 0, and 1 plus 5x square upon 1 plus 3x square minus 1, right? If we have a function, we have function like limit x tends to 0 or infinity, whatever, like f of 1 plus f of x, right? And here we have g of x. So in that case, it will, if it's a form of 1 raised to the power infinity, so we write in this form. Okay. So sir, I'll explain you in detail. So now limit x raised to x, limit x tends to 0, and here we need to write 1 upon x square, right? We'll take LCM. So 1 plus 5x square minus 1 minus 3x square, and 1 upon x square. So that is cancelled out, and 3x square upon 1 plus 3x square, and 1 upon x square, right?